Why are you running like that?
Because he probably really has to pee. Graph them however you want, which means you could make a table of values if you want, but of course that would be silly. The smart thing to do would be to isolate y. 4y equals negative 3x plus 24. Y equals negative 3/4 x plus 6. And then I would graph it. Down, 1, 2, 3. And there would be my line. Not a great line. Yeah? Now, what information does this give us right away? Just by looking at it. Slope and y-intercept, correct? All right. This one. Negative 3y equals 6x minus 33. Y equals negative 2x plus 11. Oh no, 11 goes off the graph, but no big deal. And there is our solution. What is it? 4, 4, 3. Cool? Everybody agree? All right, we've done one experiment. We don't do conclusions till we finish our experiments, right? So we've done an experiment. This tells us, again, slope and y-intercept. Right? Okay. I got another one I want to graph. Let's graph it. Blue and pink. The blue one. 4y equals negative 2x plus 12. Y equals negative 1/2 x plus 3. Yeah? 1, 2, 3. Down 1, right 2, down 1, right 2, down 1, right 2. And there's my line. Yeah? Yeah. Pink one. 2y equals negative x minus 12. Y equals negative 1/2 x minus 6. 6. Second experiment. Everybody cool? Now, we have done 2 experiments. We're going to do a third, and then we're going to come back and talk about conclusions. Everybody good? Okay, turn the page over. Blue, pink. 3y equals negative 2x plus 5. Y equals negative 2/3 x plus 5/3. Yes? Everyone agree? Okay. If I were going to graph that, I would need to go to 5/3. What should I do to my graph? Change the scale to make 1, 2, 3. What number should go right there? 1, which is how many thirds? 3/3. I need to go up to 5/3, yes? If I keep the same scale on the bottom, can I count for slope? Yes. Everyone agree? And then the pink one. Y is already isolated, so negative 2/3 x plus 5/3, which is 10/6, correct? What do you see? More than parallel. They're the exact same line, yes? All right, now, in all 6 experiments, what 2 pieces of information did every single equation give us? Slope and y-intercept. What would you do if I asked you to compare the slopes and the y-intercepts in this first one? How would you compare? What would you say about the slopes and the y-intercepts in this first experiment? Both slopes are negative. Okay. What else could you say? Both the y-intercepts positives. Excellent. What else could you say? Keep going. Talk to me. I'm asking you to compare the two of them. No. I'm asking only about slope and y-intercept. Are the slopes the same? No. Are the y-intercepts the same? No. So, if the slopes are not the same, what does that mean the lines are going to do? They are going to cross. How many times? Once. So what is the conclusion we can draw? If slopes are not equal, then there's how many solutions to this system? One. Because the lines will cross once. Everybody with me? Easy peasy, right? Makes sense. Let's look at number 2. What do you notice? Same slope. Slopes are equal, which means they are what? Which means they are parallel, which means what? Never cross, which means what? No solution. Nice job, Tushar. Right? And in number 3, what do you notice? Slopes, and y-intercepts are equal. Which means I have 2 of what? 2 what? If the slope and the y-intercept are equal of 2 equations, then what does it look like on the graph? I have what? 2 lines that are what? Exactly the same. How many times do those 2 lines intersect? All the time. Which means there's how many solutions? Infinite. Slopes and y-intercept are equal, therefore they are the same line. Therefore, there are infinite solutions. So what are our 3 options for a linear system? It can have 1 solution, no solutions, or infinite solutions. Do I need to actually solve the system to know if it's 1, 0, or infinite? No, I don't need to solve it. All I need to know is if the slopes are going to be the same or different. And the y-intercept, yes? So here are 3 systems. Don't solve them. I don't want to know what x and y are. I just want to know if it's 1, 0, or infinite. So let's have a look at this one. Will it be 1, 0, or infinite? Look close. You can tell just by looking, but you may need to do a bit of algebra. What finds me the slope immediately? Isolating y, yes? So if I isolate y here, y equals negative x minus 2, yeah? Okay, and if I isolate y here, 2y equals negative x plus 6, y equals negative 1/2 x plus 3. Are the slopes different? How many solutions? 1. I didn't even solve it. What about this one? You could isolate y, or you could just tell by looking. Please notice, x and x were the same, but the y's were different. So when I isolated y, obviously one of the x's was going to divide by 2, yes? So let's look at this guy. 3x, 6x, 5y, 10y, negative 9, 18. They're all times 2, aren't they? So if it's just multiplied by 2, isn't that the same line twice? So how many solutions? If that's the same line twice, how many solutions? Is it the same line twice, though? How could you check? What would you need to do to that equation to see if it was the exact same as that equation? make it general form. So I have 3x plus 5y minus 9 equals 0. And I have, okay, that 6 has to come over. 6x plus 10y. Then I got to bring the 18 over. Minus 18 equals 0. Are they the exact same line? 3 times 2 is 6. 5 times 2 is 10. Negative 9 times 2 is negative 18. So those are the exact same line, aren't they? So how many solutions? Infinite. They're lying on top of each other. They are always touching. And lastly, obviously we know this is 1, right? Because by process of elimination. But how would you prove it? You would put them in. Now, Tushar said general form here. Could you use any of the forms? And then you would know. Because if they were different, then they're going to cross. If they're the same, they're going to be infinite. If they're almost the same, if only C is different, then it's going to be 0 because they're going to be parallel, right? Now, why is this one a little bit harder? It's not X and Y, is it? But it's the same thing, isn't it? So let's go. You want to go general form? Could we use standard form? Would it matter? No. Since this one's in standard, let's use standard. So this guy would be 4p minus 10q equals 15. 2 times 2 is what? 5 times 2 is what? 30 divided by 2. It's not the same line, is it? But the x's and the y's are going to get me the same thing, aren't they? Because this one is going to be 4 over 10, and this one is going to be 2 over 5. Aren't they the same? So they would have the same slope, yes? So same slope means 0 solutions. Is everybody cool? Please notice there's absolutely no new math there, right? It's stuff you already know. Yeah? Okay. Now let's go on to the thing that for some reason blows your guys' minds, and I don't understand it. You can't solve word problems, and I don't get it. It boggles my mind. Here on page 251, 52, because I skipped the assignment, right, because I'm teaching a second lesson, this is all you need to do. I'm going to write in 2 different colors. Well, in different colors. 1, identify what you are looking for. In a word problem, there is always an unknown, yes? Because you're trying to find an answer. In a systems word problem, there must be how many unknowns? At least 2, or we wouldn't be using a system, would we? So, identify what you are looking for. Usually, in your grade, 2 variables. A variable is, of course, something you don't know. Then, write a statement to identify your variables. So decide what they are, and then do something with words. So we're just going to do those 2 right now. Read this first question. Sum of 2 numbers is 176. Their difference is 48. Find the numbers. What are our variables? What are the 2 unknowns we have? We know 176 and 48. What are the ones what is it in this question that we do not know? I don't know the 2 numbers, do I? So there's some number 1, and some other number 2. Everybody agree? All right, now I need to do some math. Let's do that math. These guys don't have names right now, do they? They're variables, though, yes? So what is the variable that you all insist on using? X and Y. So, let X equal number 1. Let Y equal number 2. Now, I used to have a math teacher that wouldn't give you any credit for a word problem unless you actually wrote this out as a sentence. I am not that guy. Now, Step 2. Step 3, write 2 equations. Why is it 2 equations in this case? What? Because it's a system and there's 2 unknowns. What if I had 3 unknowns? How many equations would I need? 3. What if I had 4 unknowns? 5. Good. What's the biggest amount I make you do? 2. Good. Now, here's a hint. Every sentence makes an equation. Is that a sentence? Okay. So number 1 plus number 2 is 176, right? So how do I write that in math class? X plus y equals 176. Yeah? Okay. I'll use a different shade of green for the second one. Is that a sentence? What does it say? The difference is 48. What math is difference? Subtraction. So x minus y equals 48. Now, what do you have there? It's not a dilemma. You have utter disaster, yes. Is that not a system? So what do? We solve it. Now, we're not going to solve it right now. Okay, we're going to write all 4 systems first. Because what's the harder part? The solving, once you get to there, we just did that right here. Remember? Oh, no, not there. Here. And you just did 3 puzzle sheets on solving, right? Okay. So, let's look at the next one. 4 chocolate bars and 3 pops. What are the unknown things we have here? There's chocolate bar and pop. Those are the unknowns. I need some variables, don't I? Oh, okay. So we're going to use let C equal the chocolate bar price and let P equal the pop. Agreed? Okay. Now, read the first sentence. 4 chocolate bars. 4C. And plus 3P equals 5.3. I'll change the shade. 2 chocolate bars. 2C. And 1 pop. P equals 2.2. Is that a system? Could we solve it? Damn right we could. Turn the page over. What are my 2 unknowns? Read the sentence. Don't say it out loud. Let everybody have a moment or 2 to think about it. Think of the 2 things when you read that whole problem that you do not know. Don't say it out loud. Everyone has read it, right? Do you know how much it costs to join this tennis club? No. So, there is a startup fee. Do you know how much they charge you a month? No. So those are your 2 unknowns. There's a fee at startup and a fee monthly. Can I do math with those words? No, we always give words a variable, right? So what will our variables be? Let S equal startup and let M equal the month. Now, read the sentence. After 1 month, Jen paid $260. So how many startup fees did she pay? 1, because it's a startup fee. S. Plus how many months did she pay? 1. M equals how much? 260. After 6 months, how many startup fees has she paid? 1. Because it's a startup fee. Plus how many months? 6 months. Equals 435. Does everyone see how easy this actually is? The words tell you what to do. Now, this last one is difficult. You're going to freak out about it because it's got percentages in it, yes? Okay. Read the question, decide on what your unknowns are, and decide on your variables, but don't write the math out yet. Okay? Everybody do those three things. Decide on the unknowns, assign variables, just those two things, and wait there. What is one thing that I do not know after reading this question? I don't know how much money I invested, do I? I made how many investments? How many investments did I make? 2. So I have investment 1 and investment 2, yes? Can't do math with that, so what should I give it? Variables. What variables do you guys always want to use? Great. Let X equal investment 1 and let Y equal investment 2. Now, I had $2,000. So what is the math I know? X plus Y equals $2,000 because that's what I invested, yes? Now, one investment was at 8%. One investment was at 10%, and then they paid me out $190. 8% of what? Of 2,000? 8% of investment 1. How do I write 8%? 0.08x, because x was investment 1. Plus, what's y? 0.10, right? Equals how much money? 190. Now, what about that question bothers you? The decimal. Could you get rid of it? How would you get rid of 0.08? Multiply by what, David? 10? I would multiply by 10 to get rid of 2 decimal places? I would multiply by 100, wouldn't I? So this would become 8x plus what? 10y equals what? 119,000. 2 zeros, right? Everybody cool? Of course you could leave it as decimals. I just know you guys get scared by those, so. Now, let's go back to question 2. Does this scare us? But if it did, how would I get rid of that decimal? Times by 10. Everybody cool? Now I ask you, are word problems really anything to be scared of? They tell you what to do. And once you have the systems, you just solve them. There's 4 systems there to solve, right? All right, now listen. Tonight, and for the next 19 minutes, you can work on. I don't think you probably need to spend too much time with whether or not they're going to cross or not, right? Personally. Up to you. But I would have a pretty decent look at page 254. Now, what do you notice about all 4 of those system questions examples? They're all what? Aren't they exactly the same? Choose the variable, choose the unknowns, choose the variables, read the math. All of these questions are what? The same thing. Let's just do number 10 to the same point that we did the examples. Because for some reason, when we get to the textbook, some of you are like, meh. Read that whole paragraph. I'm not going to read it to you. This isn't story time. Okay, so what are the two things we don't know there? How many bears responded and how many didn't respond, right? So I got two variables. There's a bear that responded and there's a bear that didn't respond. Let's give it some variables. Okay, which one is X? X, so which one is Y? Didn't respond. Everybody agrees? Okay, read the question. How many bears were there? So if 186 is all the bears, some bears didn't respond, some bears did, what is the math I take from that? X plus Y equals 186. The number of 94 more bears that did not respond. So more bears didn't respond, yes? So X is my responding bears, yes? X plus what? There were 94 more bears that did not respond. X plus 94 has to equal what? Y? X plus 94 equals Y? X plus 94 equals 186. Because the not responders, that number plus 94 more. Everybody cool? So now we could solve that. Now please notice, is that giant paragraph anything to be scared of? Is it more information or is it more gobbledygook? It's gobbledygook. The information is where in a math question? In the numbers. Right? Everybody cool? Yeah? All right. Go. No, you just finished Math 10. I told you we were going to finish it today.